Hey guys, what's up? It's me, PK Cubed, and welcome back to another video. In this video, I'm going to show you what I've done to our main computer file. So I'm in the main right here. Um, Basically, what I've done, it might look a little bit different. I mean, maybe a lot different since uh, the video I posted, um, the one before the last video I posted, adding registers in a bus to our 8-bit computer in Logisim. Anyway, basically I've added some RAM and some ROM for the program, and I've made a new circuit called the LCU, and I'll probably do a different episode on that, or maybe I'll do it in this one. Anyway, basically I added our program counter right here, and we've got our clear going down to this button, and we have our output going over to our RAM, or not our RAM, our program command ROM, and our program data ROM. And I'll show you how I got this to work with the LCU. Um, so basically, we've got our program counter, and it goes into our LCU, which is, by the way, it's a logic control unit. It's kind of like, well, it takes the program that we have, and it basically turns it into ones and zeros and data that controls our registers and our ALU, and it basically, you don't see any buttons or pins here anymore because the LCU is doing that for us. All we have to do is put in a program and let it do its job. So I do need to get a proper output because right now it's just looking at the output from register C. So I'll add a proper output coming off of the LCU. Um, but basically our program counter is counting through each of these lines of code, and this is in hexadecimal, by the way. So if I were to put something in, well, right now I have, so in the beginning of your program, in my case, you always want to have a um, blank kind of line of code, blank command. It's the beginning one, this one right here, and you can see that in both the command and the data. Basically, how I have it is the command will tell the LCU what to do with the data. So in this case, number one, I have a notepad over here that shows all my commands. So number one is load A right here, and so it will the number one, and that's in hexadecimal, is just 101, and then it will load A, which means it will take the data it finds in right here. It will take the data. It'll take the data and it will put it in register A. So yeah, basically it'll put the data, it will put number 5 in register A. So I've run this before, and it says 5 in register A. And then it will, the next one is 2, so that's this one. Load B, and that will do the same thing. It'll put 2 in register B right here. It's the same thing as load A, but in register B. And then finally, we've got 10. And 10 is this one down here. 10 in hexadecimal, I think, is 16, and that is A plus B equals C. So basically, takes A, adds it to B, through the LU, goes to the bus, puts it in register C. Basically, it's turning on ALU to bus and then bus to register C right here, and it can do that with the logic here. So I'll run through this program and I'll show you how this works. Basically, so we want to clear the program counter, which puts it back at 1 or 0, the first byte in our program for each of these. And then we want to tick, so we can just click on the clock. And this is our first code. So you can see it inputs 5 from the LCU because it's just taking that directly from the data ROM, and then it will add, or it will load that to register A. Now, one thing I'm going to do real quick is change up the number. So I can click on this and I'll just put in a 3, 0, 3. And that way you can see it hasn't changed yet because I set the registers to update on the falling edge. That way we don't have anything messy going on, because before it would when you turned on the clock, it would update and then it would turn off the clock, and then by the time that it got to 2, it would have updated for 1. And that could have been a problem. It wasn't really a problem, but I turned it onto the falling edge just to make sure that there were no problems. So yeah, I'll show you how this code works. So right now we are adding 3 to 2. So if we tick the clock again, register A should turn to 3 because we've got a 3 here in the input. There, now register A is 3. And I'm going to change the number 2, which is the second number it's going to add. I'm going to change that to 5. So 0, 5. And now it's going, when it goes to this one, so I can take the clock, it's not going to change yet because remember it's on the falling edge. But the program command ROM and the program data ROM are now highlighted over this 5 and this 2. So it's going to add, or it's going to load number 5 to register B. So if I tick the clock off, we now have 5 in register B. And already you can see that in register C, we have 7, and that is because, actually, no, that's because I ran it before, and it was 5 plus 2 before, so 7 is not right, and you can see it's outputting 7, but if we tick the clock once more, and once more, it should have an 8 now, yes. So now the answer is correct, and that's because 10 will do A plus B. 10 will do A plus B right here, equals C, and we'll put that in C. So you can see when we're highlighted over 10, the LCU is outputting on this wire, which goes to bus to register C, and also on this wire, ALU to bus. So it puts the answer from the ALU, puts it in the bus. You can see it's in the bus. And then it will take the bus, the 8 in the bus, and it will give it to register C. And then as you can see, when the clock ticked off, or low, then it went into register C. And what I need to do is add a proper output, like I said, so that it will output from the LCU and not just directly from register C. Because sometimes when, oh, I just closed that. Some of these are using register C, and basically I want there to be an output command, so it will output what was on register C, A, or B, or whatever it needs to, or just what was on the bus. Anyway, in the next video I'll show you what is in the LCU and how it works, but for now we now have a computer that will do basically all we program it to, and we can add programs pretty easily, and I'll show you how to do that in the next video. Thanks for watching, make sure to like and subscribe, and I'll see you later. Bye!